Welcome to the session of digital communication. And in today's lecture, we will do random process, lecture 4. Now, so far we have done random variables, CDF, PDF, statistical averages, Gaussian distribution, uniform distribution. Now, next topic is random process. Now, in unit 1, we have it's the last topic of the unit 1, the digital communication course. Now, what is random process? Now, we have done random variable which take value from its sample spaces. Now, when these values depend upon time, it's become random process. A random process is a time varying function that assigns the outcome of a random experiment to each time instant xt. Now, this is the suppose I give an example of random process. Now, temperature is the example of random process. Now, you noted down the temperature at some point at time interval 11 o'clock. You noted down the temperature at 11 o'clock today, day 1, and next day at 11 o'clock the temperature will be the different, and next day temperature will be the different, day 3. So, temperature will change with respect to time. When the function is changing with respect to time, it's become a process. Now, random process can be continuous or discrete. Random process is also known as stochastic process. Example, noise source, which can be modeled as a Gaussian random process. Now, in this example, you can see here the 3 random processes there, x1, x2, x3 and so on up to xm. Now, this random process is varying with respect to time, and this omega 1 is the value coming out from this sample spaces, omega 1, omega 2, omega 3, omega 4, and this random process is varying with respect to time. See, our random variable x which take value from its sample spaces, now it's depending upon time function also. It's become random process. Random process. Now, as this 1, 2, 3, suppose this is the our day 1 temperature reading, day 2 temperature reading, day 3 temperature reading, and with respect to time, at this point temperature will be different, at this point temperature will be different, at this point temperature will be different at day 1, and see into another variable at day 2, at this point temperature will be different, this point temperature will be different. So, our noise will also change with respect to time. So, we have to also consider that noise, that is a function of time also. So, we have to do this random process. The characteristic of random process, classification of random process, that will help us to find out the behavior of the noise signal. Now, statistics of random process, statistics of random variable we have done. हमने random variable की statistics करी थी, mean, mean square value, variance, standard distribution, right? These are the some statistics of random variable. Now, again we have to do the statistics of random process for a fixed t. Random process become a random variable with mean mu xt. Now, similarly for random process we will evaluate mean. Now, this mean will become function of t, e stands for the ensemble and the mu is denoted as a mean. Now, the formula for the mean, you know, integration x fx. Now, x is the values coming from the sample spaces and t is depending upon the sample values depending upon time. Now, here this is the PDF. To evaluate the mean for the random process, this is the formula. Now, mean is a function of t. Now, another parameter is autocorrelation function. Now, what is autocorrelation? Autocorrelation means we are finding the similarity between the two processes. two process, that is random process, or two signals, two noises, we are finding the similarity between the two signals. Now here we will take, it is denoted as a capital R, and x is the random variable at two instant of time t1 and t2. That one random process at t1 and one random process at t2. We have to find out the similarity between them. So we will use ACF function, that is autocorrelation function. Auto means same process. If it is different process, then it is become cross correlation function, CCF. Here the process is same, we are finding the similarity at time interval t1 and t2. Now this is the formula for finding the ACF, EXT1, EXT2. Now we will remove this assemble and apply the formula here for the ACF. Integration minus infinity xy fx, here the PDF is taking different value of the sample spaces x and y at the different interval t1 and t2. We'll integrate with respect to dx and dy. In general, autocorrelation function is a two variable function and measures the correlation between two samples, as I have told you. Now the classification of random process. Based on whether statistics change with time, the process is called non-stationary or stationary. Now random process is classified into stationary process or non-stationary process. Further, it can be classified at different level: strictly stationary and order stationary, and these are the specification to find out whether the process is stationary or not stationary. That will cover up in the next slide. Yes, we can change the characterize random process based on how their statistical properties change. Statistical properties like mean, ACF, joint PDF, CDF is depending upon time or not. If the statistical properties of a random process don't change with time, we call the random process stationary. Very important point. If the random process don't change with time, or random processes remain same. Suppose if xt is there and we are changing the time xt plus t1, and it will remain same, unaffected of the time, then it's known as our stationary random process. The first excuse me, then first order does not depend on time, means the random process is not depending upon the time. If we change the time, it will not change the statistics of the random process. Now strict sense stationary, in which there is some additional information added in SSS, strict sense stationary. Although mean will remain constant for the first order, mean square value remains the first order equation. In second order equation, when the two random processes compared, is also independent of the time difference. The ACF for the random process is equal to the time difference, is a function of only variable time difference. If it's independent of the time for the mean and ACF is equal to the time difference function, then it's become SSSS, strict sense stationary, where the PDF of the stationary process, this is the PDF of the stationary process, is independent of the time function and ACF is equal to the time difference. Then it's known as your SSS, strict sense stationary, and CDF is also independent of time. Then it's known as your strict sense stationary process. When the process is depending upon time, then it's called non-stationary process. If its mean is a function of time, or PDF is a function of time, or ACF is depending upon some another parameter, then it's become non-stationary process. Now another category of the random process, that is wide sense stationary process. that is also known as WSS. Now, how to judge a random process is, although its properties like mean and ACF is independent of the time and is depending upon the time difference, then is also not a stationary process, is a WSS process. For checking whether a process WSS, white and stationary, we have to find out the mean. It should be constant, or you can say independent of time. It does not depend on time, or you can say independent of time. It's give you a value, constant value. Mx is the notation of mean value. Xt bar is also denoted by the mean. Ext represent our random process, is the sample, and it will give you a constant quantity. As I have mentioned the formula for the same, minus into infinity x fx x comma t dx. It's give you a constant quantity. This is the one parameter to find out whether a process is WSS or not. Second parameter, autocorrelation function ACF, that is denoted by capital R x tau. It's give you yes, t at t plus tau. It depend upon the time difference only. ACF is depending upon only the time difference function. These are the some figure of slowly fluctuating random process, rapidly fluctuating random process. Now, in slowly fluctuating random process, you can see the variance is high. For rapidly functions, the variance is low. Variance is the spreading out of the random process from its mean value. In communication, noise and message signal can often be modeled as a stationary random process. Now, some properties of WSS. WSS is white and stationary, and these are the some properties of ACF function. ACF is very important parameter to find out whether it's a WSS or not. So, we have to do some properties of ACF. Now, here capital R is the representation of ACF function, autocorrelation function, and when tau is 0, it means Rx equal to E xt t plus tau, and when tau is 0, it's become E x square t. Now, you know what is it? It's the mean square value. When tau is 0, when the time difference we are taking is 0, then it's become xt and xt, that will give you x square t, and that is your mean square value. The autocorrelation function at tau is equal to 0 give you the maximum value, and this value is known as your mean square value, and it's always greater than equal to 0. It represents the total power of the random signal. Second point is autocorrelation function is a even function, means Rx tau will be equal to Rx minus tau, means at this point, suppose this point as 1, it will give the same value at minus 1. It's a even function. Same at the positive axis and same value we will get at the negative axis. Now, Rx tau is always greater than equal to Rx less than equal to Rx 0. The maximum value we will get at the when tau will be 0. Next, another last type of the classification of random process, that is ergodic. Now what is it? The computational of statistical averages, mean, autocorrelation function of a random process require an assemble of sample function that may not be always feasible. In many real life applications, it would be very convenient to calculate the average from a single data record, and this is possible by ergodic process. Now, what is exactly ergodic? We are calculating assemble averages. Assemble averages means we are calculating mean at fixed time, at constant time. These are the two random process x1, x2, and varying with respect to time. Now see here from this graph, assemble averages at constant time means हमने क्या करा है, टाइम को फिक्स कर दिया, कांस्टेंट कर दिया है at this point. Suppose this is the point t1, this is the point t1, and further this is the point t1, and we are collecting the samples of all these points at fixed time, that is known as your assemble averages. When the time is varying and then we collect the samples of each random process, then is known as your time averages. When time averages and assemble averages become equal, that is known as your ergodic process. Now see here, this is the mean formula, ext mean representation, it's become equal to your time averages. This is the formula to calculate the time averages, then is known as your ergodic process. Now this is the some summary that we have done in today's session. First is random process, right? Now random process is classified into stationary, non-stationary. Now stationary process is further classified into WSS, then sixth sense stationary, and last is ergodic process. So it is not necessary all WSS process is ergodic process, but all ergodic process can be your WSS process, right? Sixth sense stationary process, if a process is SSS, then it's a WSS process. For WSS, I have mentioned you have to find out the mean and ACF, right? For sixth sense stationary, you have to find out the joint, CDF and PDF. For the ergodic, you have to find out the time averages equal to your assemble averages. Then it's a ergodic process. Now we will do one example for this WSS process. Now in this example, we have to find out whether it's a process is WSS or not, WSS periodic process, or we have to find the autocorrelation, we have to find out the mean. First, see the question. Show that the sinusoidal wave with a random phase xt a cos omega ct plus phi with a phase phi uniformly distributed on 0 to pi is stationary, right? Now we have given this random process xt a cos omega Ct plus phi, or you can say theta, whatever. Now this phi is uniformly distributed. First, please give attention at here point, uniformly distributed. Which variable? That is phi. So phi is uniformly distributed, means with a range of 0 to pi. 0 to pi, and random variable is phi. Now we have done in the previous session uniformly distributed, so we can find out the PDF of this, that is f phi equal to 1 upon 2 pi minus 0, that is equal to 1 by 2 pi. Now here you can see I have noted down phi and phi, not fxx, because here is the random variable is phi, and for uniformly distribution the PDF is 1 upon b minus a. Here is the value of b 2 pi and a value is 0. So you can see 1 upon 2 pi minus 0, that will give you 1 upon 2 pi. This is the PDF. Okay. Now we have to find out the mean. Now we know in previous life mean is this is the formula to find out the mean. Now here in this formula x is the random variable, but here we are having the theta is the random variable, having a value 1 by 2 pi, and for the limit of 0 to 2 pi, elsewhere it's 0. So here we are changing the limit also. Limit will become 0 to 2 pi, because we are here the variable is x, here is the variable will become phi, and we can replace fx xt by f theta by t, that is 1 by 2 pi, and this x will be replaced by our random process, that is a cos omega ct plus ka phi. Right? Simple. We are equating the value. After solving this, a will come out 0 2 pi cos omega ct plus phi d phi. Now if we integrate this cos omega ct plus phi with a limit of 0 to 2 pi, it will give you 0, because it's a even function. Because we are integrating a sinusoidal signal, this is the property. If integrating 0 to 2 pi, if we integrate it, that will give you the sine, and sine 0 is 0 and 2 pi is also 0. So it will give you mean 0. Right? So we have calculated mean mxt, or you can say assemble ext, it is 0. Now we have first part we have calculated, find mean. Second part is autocorrelation, and third part is it WSS, random process or not? For WSS we know its mean should be constant. Now here you are getting 0 value, means it's not depending upon time. The first property is satisfied for WSS, or mean is constant. Now second, we have to find out the autocorrelation function ACF. ACF we have to show that it should be equal to time difference. right? Excuse me. In next slide, see, mean is a constant. We have calculated mu xt, ext 0 to 2 pi. Here is the representation theta. We have taken phi, so there is no confusion. It will give you 0, and f theta theta is equal to 1 to pi from the range of 0 to pi. Now we are calculating ACF. Autocorrelation function depends only on the time difference, that we have to prove it. Now here you can see Rx is the autocorrelation function at two different time t and t plus tau. Here we can write a symbol of xt and xt plus tau. Right? Now we are putting the value of here xt. Xt is value a cos omega ct plus theta. Here we are considering theta, and a cos omega ct plus tau plus theta, right? And we have to find out the ensemble of these two process. Now this a combined, that will give you a square, right? Omega ct plus theta and omega ct, we are opening this bracket, omega c plus omega c tau and phi, right? In the next step, we are applying the formula cos a cos b. If we multiply 2 and divide by 2, then 2 cos a cos b formula, that is cos a plus b cos a minus b. So here 2 will be multiply and divide, that will give you a square by 2. Now a will come out from this ensemble function, because a is a constant quantity and phi is the variable, so it's not coming out from this ensemble function. Now here you can see, when we are adding this a cos b, that will give you 2 omega ct plus omega c tau plus ka 2 phi, right? And plus cos a plus b and cos a minus b. So here we are separating this term, a square by 2, ensemble of a minus b. Now here we are minus this angle with this. Now it will give you only omega c tau, because omega c t cancel by this, phi is cancelled by this, we have left with this term, omega c tau, right? Now here, if we solve this equation, we remove this ensemble and we integrate with respect to 0 to 2 pi this function and 1 by 2 pi d theta, and it will give you 0, because if we integrate cos function with the limit of 0 to 2 pi, it will give you 0. So this whole term will become 0. We have left only with this term. Now here you can see a square by 2 ensemble cos omega c tau. Now here there is all this function, all this quantity is constant, there is no theta is there, so it will come out from this ensemble. So we have left with this a square by 2 cos omega c tau. Now ACF is it's 0 and plus a square by 2 cos omega c tau. Now we can see this ACF, this Rx tau is depending upon this time difference, that we have to prove it, and we have proved already. Now ACF is depending upon time difference. No other quantity is present in this term, so WSS property is satisfying, so it's a WSS process. We have done the mean and we have done the calculated the ACF, so it's a WSS process. Now we have to find out whether it's a WSS periodic or not. Now here you can see, if we draw this function cos having a value a square by 2, so you can see it's a periodic with a time interval of this. So it's a periodic. That is very important question in exam point of view. A process is given and you have to find out whether it's a WSS or not. It's always come in final exam. Right? That's it. So far we have completed our unit 1. This is the last topic, and see you for the next session, unit 2. Thank you.